this module, we will learn something called the continuously habitable zone, or the CHZ. What does that mean? From all the knowledge we have about life, water is a very essential element for life, right? So, scientists have basically taken the solar system and they have computed the region within which water can remain in liquid or vapor form or frozen form the whole time. Okay, this is essential for life. If the region is got water in some form, then we call it the continuously habitable zone. So, if you assume for a moment that sun is at the center of this slightly elliptical orbit, and we have the planets that we know of, Mercury, Venus, Earth and Mars, we know for sure that there is life on Earth, right. We are looking for life elsewhere in the solar system, more specifically on Mars for now, because we have some evidence that there has been water on the surface, or maybe there is water under the surface, whereas Venus we know has 460 degrees centigrade temperature on the surface. So, we do not know whether there is life or if there is a different form of life. So, given that the life form we know needs water, this blue zone here is the habitable zone, okay? And you can see that there are two times here shown as time t0 and time t1. What is happening? Basically, since the beginning of the solar system, which is about 4.6 billion years ago, sun has been changing in its luminosity and energy, which means the planets that have been formed, which are currently in the continuous habitable zone, may not be so in the future. What does that mean? Basically, sun has a lot of hydrogen. There is nuclear fusion going on, which converts hydrogen into helium. Helium is heavier than hydrogen, so helium has larger gravity. When fusion happens, temperature increases, so the sun wants to expand, but the helium increases the gravity, so the sun wants to compress. The net result is that sun is getting warmer and warmer over time, and his energy is reaching more and more towards Earth, which means all the water that is on Earth now, in about 100 million years in the future, it will be warm enough to convert everything into water vapor. Right. So, you can see that when we started at T0, the continuously habitable zone was larger because the sun was colder, and at present the continuously habitable zone is here. In the future, the continuously habitable zone will expand. Okay. So, in 5 billion years, we know that sun will become a red giant and then a white dwarf and so on and so forth, which are astrophysical terms, which we will not explain now. But essentially what you have to think of is, do we know if there is life on Mars? Well, if it is outside the continuously habitable zone as we describe here, does that mean there is no life on Mars? Not necessarily true, because if you go on Earth and you look at 3 kilometers under the ice on Antarctica, there is a freshwater lake which has been under ice for millions of years. So, it has not seen sunlight, we do not know how much oxygen there is, but we have plenty of evidence that there is life in this lake 3 kilometers below a solid ice. So, the main question then becomes, what are the conditions under which life can survive? Mars we know is at almost minus 50 degrees centigrade, and all the evidence we are getting from the missions to Mars essentially say that the surface seems to be very dry and dusty. There is no rain as far as we know. Maybe at the poles there is some frozen water close to the surface or below the surface. Does that mean that this frozen water or some form of water below the surface still has some form of life on it? We do not know that. So, essentially you can expand this argument in many directions. Did the life originate on Earth, or did it originate before on Mars or somewhere else and get thrown onto Earth and then settle on Earth, and so on. So, the continuous habitable zone exclusively focuses on water where it is available around the sun in this kind of a zone, and how this zone is changing in time. But within that, we have to always ask the question, does life always rely on water for its survival, or can it survive without water? If so, what are the temperatures at which it can survive? So, on Earth you do other things. You go to something like a hydrothermal vent deep under the ocean, which is spewing this noxious sulfuric acid kind of water at almost 120 degrees, and there are still bacteria living down there with no oxygen. So, life can survive at very extreme conditions. So, anything you can understand about the extreme conditions under which life can survive can help you when you go to other planets and look for evidence of life. So, the continuously habitable zone is just one framework where we are just tracking water and its existence in the solar system around the sun, and where it is going to remain in a usable form for life in terms of ice, water, or water vapor near the surface. This is why we call it the continuously habitable zone, or the CHZ. There are questions on it that will follow. You can work on them, and you can combine them with other modules to see how we can use this concept of CHZ to answer some of the important questions about life.